Sushruta for NEET is now available on the Google Play Store. Try it out for free.
Hi students, so we will be continuing with our discussion of the optics program. So as you know, just to remind you or provide a recap what we did last time, this year we have decided to do optics with class 11, and this is particularly so because the material is, of course, I think belongs somewhat in class 11. At least some parts belong in class 11, and because we wanted to reorient towards that system. Otherwise, you end up with too much in class 12. So if you look at the books, so let me introduce you to the books that we suggest. So there is Professor H.C. Verma's book, and Professor Verma's book does photoelectricity and electromagnetic waves in class 12, as will we, and then they also look at X-rays, in that context, So these are different topics, which are class 12 topics. Now, in the class 11 topics, we recommend students using the part 1 of H.C. Verma over and above the NCERT book. The NCERT book is a huge plus, but if you opt for our tablet solution, right, then it also works out very well. If you opt for a tablet solution, in photometry is covered. Optical instruments and geometric optics are in chapters 18 and 19, and then Professor Verma discusses the details of focal and photometry as well in as he completes and winds down the chapters in with respect to light. He has 1, 2, 3, 4, 5, 6 chapters with respect to light, and of course he starts out with is it a wave or a particle, and then he goes in great detail. Highly recommended book. I sought the blessings of Professor H.C. Verma before I launched JnanaMarga's physics program. So he is in many ways our also supportive of all his students, and that's why he has written his book with great love and affection and great care. So Professor H.C. Verma's book we suggest for all students. Now, having done that, we also very strongly suggest that the student gets our app. Once you get our app, you are in great shape to proceed forward. Okay, the JnanaMarga apps are twofold. Yesterday we started our Guru Diksha program, which is to help class 11 students. Now I'll give you another free book. Okay, let me do that first. Okay, before I go to the JnanaMarga program. Okay, so many students. Let me share my screen. Okay, see, we don't include this book with our NEET JEE apps. Okay, but we definitely include this book with our AP Physics and our AP Physics 1 and AP Physics C apps for the American students. But this is a free book. Okay, so this is AP Physics, College Physics for AP courses, and it is a fantastic book. Okay, so it starts with physics and it goes on to Newton's laws, etc., and dynamics, and then they go all the way. They go all the way. Work, power, energy, linear momentum, fluid statics, fluid dynamics, heat, and then thermodynamics, oscillatory motion and waves, physics for hearing, and then they go on to electric charge, circuits, magnetism, Faraday, electromagnetic waves, and geometry optics. So laws of refraction, laws of reflection, chapter 25, and then visual and optical instruments, and then wave optics. Okay, so all this material is excellent. And finally, they deal with special relativity and introduce quantum physics as well. Fantastic book. I would highly recommend students taking. Let me add it also to here. Let me add it, so for students who are not seeing this, this is the recommended go-to if you are interested in AP. But also, if it is a very good supplementary material for students who say, I don't want to purchase HC Verma. HC Verma is only 300 rupees, 400 rupees for one copy, 300 rupees for the other. Now, if you don't want to do that, then we also have this book. Next year we are going to index this book and help students understand. So for instance, if you wanted to do problems and exercises relating to optics, you can also go here. So these are very good problems and exercises, and they're worth doing. Okay, so page is taking some time to load, but sometimes pages take a few minutes to load. Okay, so it's all free. Note the important detail. It's all free. It is provided by openstacks.org. My highlights and notes. Log in to view your highlights and notes. Very beautiful. Now, here are problems and exercises. The laws of reflection, so beautifully laid out. Okay, and so you can easily look at these concepts. And then you look at some of these questions to help you better understand the material. Like, what is the ratio of speed of red light to white light in diamond? Okay, so these help you understand. A narrow beam of light containing wavelength goes from polystyrene to air. How far would they have to travel to be separated by 1 nanometer? So that is incident angle. Refracted angles are different, right? So when is red and when is violet, right? So we already discussed that last class, right? So image formation by lenses. Okay, so these are image formation by mirrors. These are beautiful ideas that students can gain a lot from. Okay, so now let me return to having shown you this, having introduced the textbooks. Let me also take you to the JnanaMarga apps. Okay, the JnanaMarga apps. Okay, 1 minute, 1 minute. Okay, our two flagship apps, Ramanujan for JE. Ramanujan for JE is available, from our from the Google Play Store, play.google.com, and the ID is com. You just go to on your cell phone. You go to the Play Store. It will have this kind of an icon. So you click that icon and you type com.jnanamarga.ramanujan, and that will take you straight to this page. Okay, the first app that you see with Ramanujan's picture is our app. Okay, and you download the Ramanujan app. Then there is also our test app, com.jnanamarga.test app. Okay, so you have both Ramanujan and you have the test app, and we also have this app called Sushruta. Okay, so Sushruta is our third app that we have, and these three apps, are the centerpiece of how students prepare for NEET and JEE using our apps. The test prep app has full length tests, and these are timed tests. These are to help you understand how well you are doing. I suggest going to test prep not now. You're all class 11 students. Start, at maybe you should take your first test, after you've completed all the portions for 2 years. So that should be somewhere around, the same time next year, same as this time, because you're a class 11 students, same time as this time next year, after completing the portions. You should be studying, you should be ahead of your class 12 class, and you should have finished most of the material by that time. Okay, then you should take a first test, then that will give you an idea of how difficult the JEE exams are, and how much effort it takes to prepare. Okay, NEET students also, NEET students have more time. You should take your first test maybe in December of your class 12, and try to finish all the material by that time. Okay, so so that's how I recommend students, getting themselves ready. We are looking for top-notch students to come and join our program and make us a success as well. We are only not as successful as we ourselves are, but how successful you are. Okay, so today let me continue with refraction optics at spherical surfaces, and then we will move on to reflection optics as well, if we have time. Then we'll go to ray optics, then we'll mainly look at the optical instruments. Okay, so there's a lot to go. So first let's understand the sign conventions. Okay, now this is a curved spherical surface which is refracting. Okay, so now this is the y-axis, and this is where the object is. Okay, so the object is, there is light from the object hitting the lens. Okay, so from here it is hitting the lens. Therefore, what happens to at the lens, right? Sin I by sin R, Snell's law operates. Okay, so this object, a ray of light from this object hits the lens. So you draw the normal at the point of contact with the lens, and then you do sin I by sin R, and that will give you this angle. Sin I divided by sin R will be N2 divided by N1. Okay, so now N2 is greater than N1. Now, when we do optics, right, we say this is a minus U and this is a plus U. This is minus U and minus V. Okay, when a object experiences refraction and goes that way, right, we say that it is that it will then appear on this side around here. We say, sometimes they say that that's a real object. Okay? Now, in the other case, when you have this kind of a lens, okay, this typically is called a convex lens. This is called a concave, okay, or in this case, concave surface. Right? It's not a full lens. No. Typically, a lens will be biconvex or biconcave. Okay? So here, it is just a convex surface. Then this is a concave surface. So here you have the object at O. Now it goes there, then it is refracted, right? So this angle to this angle, right? Now the normal will go directly to the C, right? Center, to the center of the curvature, right? So normal is the line joining this and that will be perpendicular to the tangent. See, that's the geometry of lenses, right? So you look at, let's say there was a perpendicular surface exactly at that point, right? Now, like that, so where do you have to go to draw the normal? The center of the circle. So draw the radius from the center of the circle to that point. That will be the normal, and then you will have your sin I by sin R around that normal. Now, when it gets refracted like this on a concave surface, right, the normal is drawn from the center C of that concave surface, and the image itself will appear behind, almost like it's behind you. It's a virtual image. In this case, the negative V, right? It looks like it is behind you, right? So the negative V implies that it is a virtual image. Okay. So that is the sign convention around it. Okay. And so for a small aperture, the paraxial approximation is valid. A small aperture is that. What is the paraxial approximation? Sin I equals I, right? Sin R equals R, right? So now, relations between, so sin I by sin R equals N2 by N1. Now, if you had N2 and N1 and one of them was not 1, right? Then you have this formula, N2 by V minus N1 by U equals N2 minus N1 by R. Please memorize this formula, N2 by V, right, minus N1 by U equals N2 minus N1 by R. But sometimes the U will be the U and the V will change sign. Okay. Now let's look at this. So what is the paraxial approximation? Tan theta equals sin theta equals alpha, right? So so N2 by V minus N1 by U equals N2 minus N1 by R. N2 is greater than N1. So now reflected light can be minimized by using an anti-reflection coating. Okay. So what is that? What does that tell you? See, that is the star here. Okay. Now, if you had a lens and you coated it with an anti-reflective coating, then this, see, when you have refraction, there will also be some reflection. I'm sure you've seen that also. Okay. So there is a little reflection, where some of the light goes that way. But if you apply that anti-reflective coating, all the light will go across. Why do you do that? Like, let me give you the important case where they do that now. The important case is when you have a lens placed on top of a solar panel. Okay, so you have a lens, okay, and then the lens moves, right? Typically solar panels, the aim is to keep it perpendicular to the sun. Okay, so the sun moves like that, right? And with that, you move the panel as well. Okay, now some places to conserve, silicon, although now these days silicon is so cheap that they don't do it. Okay, what they do is they put a small lens on top. Okay, because they put that lens on top, the lens will move. Okay, sometimes they'll only move the lens. Sometimes they'll only they'll move both the lens and the panel. Very interesting when you look at those details as well. Okay, so now if you put an anti-reflection coating on top of the lens, then there is not that bounce off of the light. You see, everything gets channeled, and you want that. Okay, so now sin I by sin R equals N2 by N1. So let's understand the angles. Okay, the I is the incident angle. The this angle is the R is the refracted angle. Okay. Now, when you use that, compare how are they related to alpha and beta. Okay. Now, if you draw this line and you extended it to all the way to the center, this is the normal, right? I equals alpha plus beta. Exterior angle equals sum of interior opposite angles. Alpha plus beta equals I. R equals beta minus gamma. Again, same thing, right? R plus gamma equals beta, right? So R equals beta minus gamma. Okay, and it is using this and applying the sin I equals I, sin R equals R, that you then end up with this applying sign convention. You end up with this formula. N1 times MD by OP plus MD by CP plus N2 times MD by CP minus MD by OP. Okay, so this MD by OP is what? MD by OP. It is opposite side by adjacent side for alpha. So it is tan alpha. Tan alpha is approximately alpha. Okay, so this is not always true, but it is true when under certain circumstances. Okay, for small angles. Okay, so and that is how he is deriving this formula: n2 by v minus n1 by u equals n2 minus n1 by r. It is just using small angles. Sin I equals I, right? Sin R equals R, and then substituting for those into those equations. Okay, so MD by CP is what? Tan alpha. Okay, so MD by CP is tan alpha. MD by IP is what? MD by IP is tan gamma. Okay, so using all that, right, and he writes that as separately. Okay, so then N1 by UOP equals minus U, CP equals R, IP equals V. He plugs that into this equation and he ends up with N1 by U, N1 by U, or N2 by V minus N1 by U equals N2 minus N1 by R. Okay, now if you have a similar equation, you just change the sign in the case of this, in the case of the concave lens also. Just have to change the sign. Remember the sign convention we did. So now when we look at refraction by lens, right? A lens is what? Biconcave, right? You have N1, N2, N1, right? So lens is biconcave or biconvex. Okay, so now when you have this, you twice apply this N2 by V minus N1 by U because N2 minus N1 by R. You apply it again. Okay, and you are now interested in this V1 and V2. So it goes from N1 to N2 and then back to N1, right? Right? That's how you have a concave lens. Starts in air, goes into glass, and then exits back into air, right? So now when you rewrite combine these two equations, and you write an equation with respect to U and V, you end up with this formula: 1 by V minus 1 by U equals N2 minus N1, N2 by N1 minus 1 times 1 by R1 minus 1 by R2. Okay, now typically this becomes 0.5. Okay, N2 by N1 equals 1. Okay, therefore you end up with 1 by V minus 1 by U equals 1 by N, 1 by F, which is called the lens maker's formula. What is F? Okay, F is called the principal focus, point of principal focus, and is a length. Okay, the focal length is called the focal length. Focal length equals, so this is 0.5 times 1 by R1 minus 1 by R2. Now let's say R1 and R2 are the same, right? So then you have so it will then be additive, right? So then you end up with this formula. If R1 equals minus R2 equals R, you end up with 1 by F equals 2 by R times N minus 1. And if N is 1.5, you end up with R equals 2 times N minus 1. The focal length equals R divided by 2 times N minus 1. Okay. So, for symmetric biconcave, it is minus R by 2 times N minus 1. Okay. So that is the focal length, 1 by U minus 1 by V equals 1 by v minus 1 by u equals 1 by f, and this is called the lens maker's formula. Okay, so remember this equation as we go into the next set of slides, and we look to derive the next set of equations. All right, so so the next set of slides we call ray optics. Okay? So this is a simple set of slides as well, and this, when you use our app, you will get these YouTube links. These are all IIT PAL YouTube links. Okay, so you must listen to those YouTubes carefully. I go through them fast so that not to replace the IIT PAL. It is done so that you can understand the material quickly, and then you can read the textbook and then also listen in more detail to the. Okay. So now, what is the unit of measurement of power of a lens? Okay, the unit of measurement of power of a lens is uh, is diopters, and it is has a term called D. D equals 1 by f. F is what? F is a measure of length, right? So this is 1 over length. The dimensions of a diopter is 1 over length. F is a focal length in meters. Diopter is in 1 over meter. Okay, and the lens surface power can be found with the refractive index. Okay, so power in diopters is therefore proportional to 1 over f. The power of a lens is proportional to 1 over f. Remember, what is f? F is called the focal length. 1 by v minus 1 by u equals 1 by f, right? So intuitively, the converging capability. What is the power of a lens? It is how sharply it converges. Okay, if it converges very sharply, then it has a greater power. Okay, so smaller the f, greater the power. Okay, so if it converges right in front of the lens, then you have great power in the lens. Okay, so remember that. So if what is the power? It is also called D for diopter. Power equal, if you have a lens with a focal length of 50 centimeters, power equals 1 by 50 or 1 by 0.5. 1 by 0.5 is 2 diopters. Similarly, in a concave length, 40 centimeters, 1 by minus 0.5. Okay, so 1 by v minus 1 by u equals 1 by f, or 1 by v minus 1 by u equals power, merely power. Okay, so we did two simple calculations to calculate the power of these two lenses. One is a concave lens, one is a convex lens with a focal length of 50 centimeters. There is a concave length focal length of 40 centimeters. Notice that one is 2 diopters and the other is minus 2.5. Notice the conventions, right? Because f is negative, p is also negative. Okay, so learn to use that. An observer looks at a distance tree of height 10 meters with a telescope of magnifying power 20. To the observer, the tree appears what? Power is also v by u. What is v? V is the length, right? So you can say that the tree is going to if it is 20, right? If the magnifying power is positive 20, then 1 by v plus 1 by u equals 1 by f. Now v is v by u equals 20. Therefore, power is 20. Therefore, f is so you have 1 by 20. So if it is 10, so your u is 10, right? So 1 by 10 equals 1 by 20, 1 by plus 1 by v equals 1 by 20. So 1 by 20, minus, so when you subtract, right, you will end up with 1 by 10 minus 1 by 20, which is also 1 by 20, right? So v will also be 20 times. Okay, so it will appear 20 times nearer. Okay, so the tree appears to be 20 times nearer. Okay, so so that's what will happen. Okay, so combination of lenses. When you have two lenses, when two lenses are used in combination, the first one forms an image that then serves as the object for the second lens. So we are next going to go into optics, right? Into optical instruments. And the two most or three most common optical instruments that people use are as follows. The first optical instrument that people used was the telescope, right? They used the telescope to see distant things, right? It was used in navigation, in the seas, the high seas. People used telescope to see how far distant lands are. The sailor, it was a sailor's instrument along with the compass. They used the compass and the telescope to explore the oceans. Okay. Now, the second instrument that they used, right, was after the discovery of extremely small things and used in jewelry, as well as, of course, today in the study of microbes, right, was the microscope. Okay. Now, how are the two related? We will look into that next. Okay. So the telescope, the microscope, and eventually they introduced a third way of magnification, which is called the electron microscope. We'll briefly look at that as well in the next class. Okay. So now, typically, this is part of the science of many years, right? Because these things are many almost 1,000 years old, right? Some of the study of this and of at least 500, 600 years old in terms of when they were used in a very big way. Okay, so now when combination of lenses are used, the first forms an image which then serves as the object to the second. Okay, so let's once again look at 1 by v minus 1 by u equals 1 by f, right? So now using that formula, when you have multiple lenses, when you have to combine two lenses, right? What do you do? So sometimes you have two different types of glass. Okay, the first glass is ground glass, and second glass is flint glass. Each will have a different refractive index. Okay, so when you combine two thin lenses, right? Combination of lenses in contact, combine two thin lenses, L1 and L2 of focal length, F1 and F2. They are placed in contact. What will be the focal length of the combination? Focal length of the combination of several lenses is 1 by f equals 1 by f1 plus 1 by f2 plus 1 by f3 plus 1 by f4, almost like resistors in parallel. Okay, 1 by f equivalent equals 1 by f1 plus 1 by f2 plus 1 by f3 plus 1 by f4. The power is just the summation of the powers, p1 plus p2 plus p3 plus p4. So, but you must note that they have, read the note, f1, f2, f3, f4 have different signs. They are positive or negative. P equivalent is the algebraic sum of the powers of the individual lenses. What is the focal length of the combination of two lenses? Convex lens of focal length 30, the concave lens of focal length 20. So is the combination converging or diverging? Okay, so if the f1 is 30, f2 is 20, f equivalent is 1 by f equivalent equals 1 by 30 minus 1 by 20. So 1 by f equals 1 by 30 minus 1 by 20. It is going to be minus. Therefore, it will be a diverging type. Okay, so because 1 by 20 is 0.05, 1 by 30 is 0.03, it will be negative 0.0166. Okay, so you do the LCM, you will end up with 30 times 20 is 600, and 30 minus 20 is 10. So 10 by 600 negative 1 by 60. Okay, so the combination will be 1 by 60. Therefore, the net F will be 6. The net F equivalent will be 60, right? Therefore, you can see, and in fact, it is a diverging temperature. Therefore, it is minus 60, right? So notice how the professor does the problem, right? And we also did the same, and we reached 60. Simple method. Convergent doublet of separated lenses corrected for spherical aberration has a resultant focal length of 10 centimeters. Separation between the lenses is 2 centimeters. So now, what do we do about the separation? Okay, the separation is also worked into the formula. Okay, the separation also, you do F1 F2 divided by F1 plus F2 if there is no separation. Now, if there is a separation, you introduce a minus D in the denominator. Okay, so F1 F2, convergent doublet of separated lenses corrected for spherical aberration has a resultant focal length of 10. Okay, the separation is this. Okay, so F1, the focal lengths of the component lenses are what? Okay, F1 minus F2 equals 2. Okay, so what is he telling you there? Okay, he's telling you that the resultant focal length F is F1 F2 divided by F1 plus F2 minus D is 10, right? And F1 minus F2 is also 2. Okay, so the separation between, when you correct for spherical aberration, right, you have to correspondingly separate it by the difference in their distances. Okay, so that is the key point there. When you do the correction, the difference in the focal lengths should be the distance by which you should separate them. Okay, so when you do that, you have F1 minus F2 equals 2, then F1 F2 divided by F1 plus F2 minus D equals 10. It's 2 equations and 2 unknowns. When you solve, you end up with a square law equation. F2 square equals 18F2, F2 equals 18. Therefore, F1 is 2 plus 18. Therefore, you have 18 and 20. Notice all the answers also differ by 2. Okay, they want to make sure you understood this logic. Okay, remember this. Okay, convergent doublet. So, what does convergent mean? Convergent means that the focal lengths are positive. 2 centimeters, remember, the concave lens has negative focal length. A 2 centimeter long needle is placed erect at a distance of 10 cm. That is V, right? V is 10 cm in front of a biconvex concave lens of focal length 10. So 1 by 1 by U is 2, right? 1 by U minus 1 by V equals 1 by 10. Negative 1 by 10 because it's concave. Determine the position, the size of the image. The ratio of the sizes, V by U, the ratio of the sizes is also the focal length, is the power, right? So if it is 2, first let's determine the size. It was 2 and the focal length is 10. V by U is 10, right, or 0.1, right? Therefore, 2.02 divided by the position, the size of the image divided by 0.02 equals 0.1. Okay, so V by U is the magnification, right? Magnification is 0.5. Okay, so the size of the lens, right? 1 by v plus minus 1 by u equals 1 by f. U is 10 centimeters. F is also 10. Therefore, minus 1 by 10, minus 1 by 10, you have minus 1 by 20. Therefore, v equals minus 5, right? So v by u is your magnification, right? So v by u is what? V by u, we got u to be 10, v to be 5 using the lens maker's formula, right? Minus 1, so u is 10 here, v is to be determined, we determined it to be 5, right? Using 1 by u minus 1 by v equals 1 by f, right? So f was negative because it's a concave lens. U was u is always by convention positive, right? Therefore, minus 1 by 10 minus 1 by 10 equals minus 2 by 10. So v equals minus 5. Therefore, now what is the magnification? V by u is 0.5. So now the magnification is v by u. Therefore, using that formula, right? You then look at the original image was 2 centimeters. Therefore, 0.5 times 2 is 1 centimeter. Remember that a concave lens will make things smaller. Convex lens will make things bigger, right? So that is what they are saying, right? So, and the image that is produced is a virtual image in a concave lens. Size of the image is smaller, and because it is projected like this. Image is like this. It projects back into the into the same side as the as the object. Okay, so it appears smaller and is projected back into the same side as the object. If it was a concave lens, it will appear to be on the other side, right? And you will have 1 by v minus 1 by u equals 1 by f. You will have corresponding results. You'll have a positive for v. Okay. For convex lens. So now here's the convex lens. So remember 1 by v plus 1 by u equals 1 by f. So uv divided by u plus v is f, right? So a convex lens is placed at 10 centimeters from a light source, makes a sharp image on the screen, kept 10 meters from the source. So u and v, 10 and 10, right? So now a glass block of 1.5 centimeters is placed in contact with the light source. Okay. Now, so what is the to get the sharp now a glass block is placed in contact with the light source. Okay. To get the sharp image again, the screen is shifted by a distance d. Okay. So now what happens, right? Because so you have the now the glass block is placed in contact with the light source. So now there is going to be a refraction as a result, right? So what is the refraction, right? So u is now going to become u prime. U prime minus u is going to be the thickness times 1 minus 1 over the refractive index. Refractive index of glass is 1.5, right? So 1 minus 1.5 is 1 minus 1 over 1.5 is about 0.5, is about 0.6666, right? So 0.666 times 1, or it is actually 1 by 3, right? So 1 by 3, right? So this so you have 1 minus 2 by 3, which is 1 by 3, right? So 1.5 times 1 by 3 is 0.5. So u prime will be 9.5 centimeters. Originally it was 10 centimeters, right? So u prime is now 9.5. So now when you do uv divided by u plus v using that new length, right? So the new v is going to be what? F is 5 centimeters, right? So using the 1 by u plus 1 by v, right? So now there's a u prime and a v prime, right? So now the object is appearing slightly closer because of that, and therefore they have to move the screen a little bit. Okay, so by how much do they have to move the screen? So he finds that the v is 10.55. Because the v is 10.55, you have to move the screen 0.55 away from the lens, so that you end up with a v of 10.55 rather than 10. So then only you will get a sharp image on the other side. Okay, particular lens made of glass of refractive index 1.5 has a focal length f in air. Okay, now when the lens is immersed in a liquid, the focal length increases to 4f. Determine the refractive index of the liquid. So now you must use the original formula. 1 by f equals n2 by n1 minus 1 times 1 by r1 minus 1 by r2. Right? So, we already know 1 by f equals n2 by n1 minus 1 times 2 by r. Right? You remember, and and in one case, one was air, so n minus 1, right? N1 was 1, so n minus 1 times 2 by r, right? So that was the original formula. So that gave you the original f, right? Now, when you put it in a liquid, right, you end up with, see, this is the air formula, right? So now when you put it in a liquid, you end up with 1 by 4 because of the L, okay? So what you do get is glass, so G is 1.5, right? A is 1. So this is 0.5, right? 0.5 times 1 by, times 2 by R. 0.5 times 2 by R, right? 1 by F equals 0.5 times 2 by R, okay? So using that, and then similarly 1 by 4F equals 0.5 times, equals something else, Ng by NL minus 1 times 2 by R, okay? So when you solve for that, you will then be able to calculate the NL, okay? Because of the 4F, okay? So when you solve for that, you will therefore end up with the corresponding value. So this formula helps you calculate this 1 by R, R1 minus 1 by R, okay? So 1 by F was what, right? So, and that is going to be based on this, right? So the F's will cancel, this will cancel, right? So you will end up with 4 equals 0.5 divided by Ng by NL minus 1. Okay. So from that, you can calculate NL. Okay. So that's the basic. You have to divide the two equations. Okay. And then you will get the ratio. The two unknowns will drop off. Okay. So, and so, this is the simple case of the refractive index. Okay. Of the lens, figure is formed at a distance. All right. So, that is, as far as we have gotten today, but I will quickly introduce, I wanted to get a little bit further today, but let me quickly introduce, telescopy, then we'll continue telescopy, but we'll do a few more problems next time with these ideas, next class, but let me quickly introduce you telescopy, okay, so that you can spend some time reading the telescopy chapter as well in the textbook. Okay, so there are the two classes of instruments. One to look at things which are far away, and the other to look at things which are very small. Okay, things that are large and far away, like the moon, right, are looked at through the telescope, or like a distant shore from a, there are the mariners would look for, use the, or the people who start wars, right, and who are trying to look at the enemy, right? Now, and of course, there are today they have discovered this, terrible use of for the telescope called the telescopic sight for the gun. You talk of something that's, uh, you know, um, you know, talk of uses of, these instruments, right? The telescope is a weapon in a person's hands also, Now, the other idea is the other more important, um, or not more important, they're both important. The other idea that we will be learning is the microscope. Okay? The compound microscope has also two lenses. So both of these, they typically have two or maybe even three lenses. Okay, so the telescope is like that. It has a small eye lens and a bigger objective lens. There is an eyepiece and an objective piece. The objective piece is closer to the object. The eyepiece is closer to the eye. Okay. Now, the telescope has a bigger objective piece and a smaller eyepiece, as you would all have noticed, right? The microscope, on the other hand, has a littler um, objective piece and a bigger eyepiece. Okay, so the objective lens forms a real image of the object close to the eye lens, from which the eye lens gives a greatly magnified virtual image. Okay, so what does that mean? Okay, so in the formula, 1 by V minus 1 by U equals 1 by F, right? So what happens when you have all the rays come from a very far distance parallel, right? That is, then what will happen is they will all converge to the focal point. Okay, all the parallel rays on a convex lens, which come from a distance, will converge to the focal point, or the position of the focal length. Why is that? Because 1 by U is 0. The U is very far, right? So U is very large, therefore 1 by U is 0, right? So 1 by V equals 1 by F, right? So now that is the idea that they are looking to take. Similarly, if you placed an object very close to F, right? So then you will see the magnification become bigger. V by U, right, will become bigger. Okay, so you want the V, if the V becomes very big, right? V by U is your magnification, right? So that's the idea behind this. Okay, 1 by V minus 1 by U equals 1 by F, right? And 1 by, and V by U equals M, right? You want the M to become very big. And that's, we also looked at this F1, F2 divided by F1 plus F2 minus D, right? So those are all the ideas that are used to produce a very high magnification. Okay, so the for the for a microscope, right? So the objective lens forms a real image of the object close to the eye lens. The objective lens, right, forms a real image close to the eye lens. Because it is so close to the eye lens, it then forms a final virtual, the eye lens will form a final virtual image which is much bigger. So it is very close to the eyepiece, and then that will get immensely magnified in terms of the final The final image is a virtual image. The first image is a real image. Therefore, you will get to see a very big virtual image, which is the aim of the compound microscope, right? So, no, remember this picture, and remember that the object, right, forms a real image first. Typically, in a convex lens, the real image is inverted, right? But the virtual image is not inverted. Virtual image will appear on the same side and same, it will not be inverted. Okay, so that is now a compound microscope. Separation between the lenses can be changed. So they will have the objective, then you have eyepiece, then you will have an adjustment knob which will adjust the length in between. Okay, and that adjustment knob will adjust the length in between. So you sometimes just need to do a little bit. That's why you spend a lot of time. I don't know, when you go to your lab in either physics, well, maybe your bio labs, right? When you have when you have to look at something like a cellular level, right? So these are amazing things to learn. So you must learn these ideas also. Okay. So now, so how does one solve problems involving, the compound microscope, right? So you have the objective, you have this one, and you have that one, right? So now, how are these related? Focal length, f objective, focal length, fi, right? So the aim is to make this virtual image almost coincide with the focal point of the eyepiece. The closer you are to the focal point of the eyepiece, the larger will be the virtual image. If you are exactly at the focal point, then you will get a big image. Okay, so that's the idea there. Okay, so the first part is to take the aim of the objective lens is to take the object and make a real image of it close to the eyepiece close to the focal point of the eyepiece. Okay, so now the magnification is LD by F, by the product of the focal lengths. What is D? What is L and what is D? Okay. Now D is is the diopters, right? D is the magnification, right? The angular magnification is D, right? And L is the distance between the focal points, capital F prime and FO and FE, right? The distance, if you see this one, right, you adjust this length, right, between this and this, that distance is said to be L. Okay, and so the magnification is L times D divided by FOFE. Okay, and so that magnification is what we are really after. Okay, so I'm going to stop here, and we will continue the discussion next class, because I've gone a few minutes over. So we will be continuing the discussion next class. Then we will go back a little bit and do a couple of problems involving lenses, and then we will continue with magnifying power, etc. Okay, but remember, now we have gone many different steps. We started with the wave nature of light and Young's double slit experiment. Then we went on to diffraction, and we then looked at the varying refractive indices of different types of light. Then we looked at refraction. Then we looked at Snell's law, and then after Snell's law, we then started looking at optics. We started with the optics of a single lens. Now we have gone to the optics involving telescoping. Okay, so I guess we are going at a rapid pace here, but this material is easily understood, by a careful student who reads, H.C. Verma, or and one can then develop that material further as we go along. Okay. So with that, I'm going to stop today's class, and tomorrow next time we will do a few problems. But my suggestion is that the student also take significant effort to download our app, to go through the lectures, and then do the necessary self-assessment, and then they will be able to proceed forward. All right. With that, I'm going to stop, and then we'll continue next week. Thank you.